Hello everyone. In the last class, we had discussed about the naming of sulfonic acid, naming of amines, naming of alcohols, and now we are continuing with the nomenclature of the functional groups. We are going to start with the thiols first. So let's quickly start. Thiols is nothing else but very similar to OH. Instead of oxygen, if you put sulfur, then it is called as thiol instead of ol. Okay, so this group itself is called thiol, and its secondary suffix is also thiol. So basically, if it is the higher priority group, we will be writing thiol in the suffix, and if it is a lower priority group, we'll be using mercapto as the word for prefix. If you talk about the generic formula is RSH, where the name is alkane thiol. Alkane represents the R group, and SH represents thiol. Okay, now for example, we have taken few examples over here. We'll quickly talk about them. So CH3SH is methane thiol. Methane is for CH3 and SH is represented by thiol. We have a common name of it and we also call it as methyl mercapto. This is a common name, by the way. You are not going to use this name anywhere in terms of Iupac name nomenclature. Next is Ethenthiol. Ethenthiol is CH3CH2SH, and again, its common name is ethyl mercapto. So common name is ethyl mercapto. So this methyl mercapto is also written as methyl mercaptan, and this methyl mercaptan has a very bad stench, and this is a clear liquid. By the way, when we talk about some gases like LPG or natural gas, LPG is the gas which we use at home, right? So all these gases do not have any distinctive smell. So we add this ethyl mercaptan in these natural gas and LPG and such gases which are very flammable, and they don't have their own smell. We add ethyl mercaptan in it so that these can get some distinguishable smell. So basically in LPG we add ethyl mercaptan, and that's the reason why whenever there is a gas leak, there is a normal cylinder, what you have at home is nothing else but the LPG gas. So whenever there is a leakage, you can smell it, and that smell itself is not of LPG. The smell is of ethyl mercaptan, basically C2H5SH. C2H5SH. This is the compound which is added to the natural gas so that we can distinguish the leak, we can figure out if there is a leak, and we can smell it, and we can stop the leakage, because the natural gas LPG, these doesn't have their own distinguishable smell. So this is a very important compound in day-to-day life also, because it is basically saving a lot of people from a lot of accidents. Okay, basically fire accidents and all that. Okay, so let's talk about next few compounds. Naming of thiols is very similar to alcohol, so that's why we are not doing a lot of examples over here. Instead of ol, we are just using thiol, so the process and everything remains same. Now look at this compound. We have SH somewhere on the third carbon. We have taken this as a main chain, so the name will become pentane 3 thiol. Now again, this particular group is not the one which is chain terminating or chain initiating group, so it can be present anywhere in the carbon chain. Look at the next compound, cyclohexane, and there is a SH, so the name will be cyclohexane thiol. Next we have is cyclopentane with SH and OH, and the name will be, okay, now here we have two functional groups. SH is there and OH is there, though both are very similar to each other, but one is more, one gets more precedence over the another. So OH has higher priority than SH, and that's why OH is the primary group, or you can say OH is the one which will be used in suffix, and SH will be used in prefix. So the name of the compound is going to be cyclopentanol. We will start numbering from here, 1, 2, and 3. So my SH is present at the third position, and the name will be 3-mercapto cyclopentanol or cyclopentan-1-ol. You can write it either way. This is about the naming of thiols. Let's move to the next group. Next group is aldehydes. What are aldehydes? CHO is the aldehyde group. Sorry. And you can also write it as C double bond OH, and one valence C carbon is linked to the principal carbon chain. So this is my functional group. It has two different suffixes. One is ul and another is carbaldehyde. Both have their own uses. So carbaldehyde is a special name we will be using in a specific conditions. In most of the cases, we will be using the suffix ul. Prefix is formyl and oxo, and again formyl and oxo both have different uses, so we will understand where we have to use formyl and where we have to use oxo. Okay, this particular group is chain initiating and terminating group. the same as COOH. So that means whenever this group is present in the carbon chain, and if it is not present with any higher priority group, in that case the position of the CHO will always remain first position. It will never be in the middle of the chain. The first compound what we have in aldehydes is HCHO. Basically it has one carbon in it, and the compound will be called as methanol. Methanol has a common name and it is called as formaldehyde. Similar way we have CH3CHO, the second compound of aldehydes. It is called as ethanol. Why ethanol? First of all, let me just write down the general formula which I had not written before. So the name of this compound is going to be alkanol. Now this is the combination of alkane plus ul here, because two vowels are together, so we are removing e. This alkane represents the R group. How many carbons are there? Not exactly how many carbons are there only in R. Basically this alkane is R plus C. That means C of CHO is also counted. So number of carbons which are present in the R group plus the carbon of aldehyde will be counted together, and the alkane will be written, and ul represents that there is an aldehyde group present over here. So here when we are writing alkanol, we don't have to ignore CHO's carbon, we have to count its carbon also. So CH3CHO, 2 carbons in total. Ethanol will be the name. Common name is acetaldehyde. Common names are important. Again we have next compound CH3CH2CHO, 3 carbons. The name is propanol. Next compound has CH3, CH2, CH, CH3 and CHO. Now here CHO looks like as if it is present in the middle of the carbon chain, but as I mentioned earlier, this particular group is chain initiating group and chain terminating group, so that means it has to get the position 1. So chain should initiate from this CHO rather than initiating from somewhere else. So here if I have to find out the longest possible chain including CHO as the first group in the carbon chain, this is how my chain would be. Right, so the position will be 1, 2, 3 and 4. Automatically aldehyde got first position, and CH3 which is left out got the second position, and the name will become 2-methyl butanol. Why butanol? 4 carbons are there, and ul is to represent aldehyde. Okay, so next compound is CHO. I have not written hydrogens over here, so it is understood that the valencies of these carbons will be fulfilled. You cannot choose the carbons to leave as it is without writing hydrogen. I'm just writing it as a shorthand because now I hope you're understanding things much better, and you can imagine that the hydrogens would be present over there. You will not write it like this ever. Okay, this is just because we want to do a little faster. That's why I'm just writing it over here. So CHO, CHO. So we have 2 aldehyde groups over here, and my chain will start from first CHO and then will end up with another CHO. Automatically it is a chain initiating and chain terminating group. Always it will be chain initiating and terminating group. So this group will be the beginning of the chain and the termination and will be at the termination of the chain. So we don't have to specifically mention position 1 and 4. When there are 2 CHOs, they have to be on the first position and the last position. So name we can directly write it as butanediol. I think I've done a spelling mistake. It should be butanediol. Yeah, so I have missed E. So this is not correct. Okay, now come to the next we have CH2 double bond CHO. So it's a 3-membered carbon chain with a CHO group in it, and we will, as I mentioned, we will start numbering from CHO only. So my double bond will get the second position, and the compound name is going to be prop 2 enol. By the way, you could have skipped writing 2. Why? Because there is no other possible position for double bond to be, so it has to be on the second position. That's why I have not mentioned 2 over here, because double bond cannot come at this position. Otherwise valencies will it will exceed the valency. So the only place where double bond can be is the second and third carbon, and hence you don't have to specifically mention it. So if they write propanol, you should know this is they're talking about this compound only, nothing else. But if you want, you can write 2 also to be a little clear in terms of naming. Next is CH triple bond CCHO. Again, it's a very similar case as 6th one, and hence the name is going to be propionyl. Position for aldehyde is first, and position for triple bond is second. Okay, so let's talk about the question number 8. In question number 8, now we have 2 functional groups. One is COH and another is CHO. So basically when we have 2 functional groups, again we will have to see which one has the higher priority, which one has the lower priority. So now carboxylic acid will definitely get precedence over aldehyde, and hence we will start numbering from carboxylic acid rather than starting numbering or starting my chain from aldehyde. So this will be 1, 2, 3, 4, 5 and 6. Now we will not terminate our chain over here. Now we can go simple straight taking, because now this is anyways acting as a branch. So branch or prefix or low priority group. So we will be considering the longest possible chain like this, and CHO will be acting as a substituent on the fourth position. So the name will be hexonic acid for this whole thing. Okay, and now CHO will be called as formyl. So this is the prefix for CHO, and it is present on the fourth position. So this is 4. Now here we have not included the CHO's carbon. We have not counted the CHO's carbon when we were counting the main chain, and that is why we have used the prefix as formyl. So when carbon of CHO is not included in naming, then we use prefix, then prefix will be formyl. Okay, now let's see another way or other case where we may be able to choose carbon as the main part of the carbon chain. So now again in the next question, if you see very carefully, I have two functional groups. One is COH and another is CHO. We will take the longest possible chain for the naming, and I'll start my chain from here. 1, 2, 3, 4, 5 and 6. So we are including the CHO because it is possible to include the CHO, but again CHO is going to be a low priority group, hence its name will come in prefix rather than coming in suffix. So suffix will be oic acid and prefix will be aldehydes prefix. But here what will be the difference? In the previous case we could not include CHO's carbon in the principal carbon chain. Here we are including the CHO's carbon in the principal carbon chain counting, and that's the reason it will have a different prefix. Now when we include carbon of CHO in naming of principal carbon chain, then prefix for CHO is oxo. So I hope you would have understood the difference. When carbon is not counted in the main chain, it is formyl. When carbon is counted in the main chain, it is oxo. So the name will be 6-oxohexanoic acid. So 6-oxo is nothing else, but it's like I have written the chain like this: C double bond OH, and then the carbon chain is like this. So this is my main chain, and oxygen is something which we are not considering as the part of the chain, or you can say the double bond O is something being considered as the functional group over here, including the carbon in the carbon chain, and for that the term is oxo. Okay, so this is important difference. You should know where formyl is being used, where oxo is used. Though it looks like in that formyl and oxo is for the same thing, but they don't have the same meaning. The meaning is different. The carbon chain name will be different if we are using formyl and if we are using oxo. Now let's see the next question, next example. What we have is, we have again two functional groups. One is COOH. Now here I have just taken two functional groups randomly. I have not taken aldehyde. It's just to show you how to name the compounds when there are two different functional groups are there. We have done many questions. I've just randomly taken. I have COOH, COCl. Now what is the COCl? This is acid chloride group. I've just taken it just like that. I mean, just to give you a break from aldehyde. So we will, if we see the higher priority group is COH, so we will start numbering from here: 1, 2, 3, 4, and comes 5. So when we are talking about this COCl group, we do not include its carbon in the principal carbon chain. We only count the carbons of the chain excluding the COCl. COCl is acid chloride group, okay, and its name is chlorocarbonyl when it will be acting as prefix. So I have written 4-chlorocarbonyl because we are not including its carbon. So there would be cases where carbons are included. There would be cases where there will be we will be excluding carbon. So COCl is another functional group. When it is acting as prefix, you have to exclude its carbon, and the name will be halocarbonyl. So halocarbonyl means depending upon what group is attached to it: bromine, chlorine, iodine, fluorine. COX will be called as halocarbonyl as a prefix, and rest of the carbon chain will be counted as one thing, as the principal carbon chain, when we have included COOH. H. So it has 4 carbons, 1, 2, 3, 4. On the fourth carbon, the COCl group is attached, and we are not including the carbon of COCl in the principal carbon chain, and the name is chlorocarbonyl. So this is one more example just to show you that we have cases where where the functional group is made up of carbon, but we are not including its carbon in the principal carbon chain because it is acting as a prefix, or it is acting as a low priority group. Okay. Now let's come back to the aldehydes. So now look at another chain. I have a chain where we have 3 CHO groups, and the chain is something like CHO, CH2, CH2, CH, CH2, CHO, CH2, CH2, CHO. Again, we have 3 CHOs and the chain is branched. So we have to try to include as many CHOs as possible in our principal carbon chain. Our chain will start from CHO, our chain will end at CHO. We will be choosing the principal carbon chain which will have maximum number of carbons. So here, if I go like this, the number of carbons will be 1, 2, 3, 4, 5, 6. 6 carbons with the 2 CHOs. Okay. And if I go straight and take this as a principal carbon chain, then I will have 2 CHOs and 1, 2, 3, 4, 5, 6, 7 carbons. So this is the longest chain including 2 CHOs. Eventually one CHO group will be out of the chain no matter whatever you do, because by any way it is not getting included in the principal carbon chain. So now CH2CHO is our branch, and 2 CHOs with 7 carbons is our principal carbon chain. So here let's write down the name of the principal carbon chain. It will be first position and the 7th position. So we can simply write heptanediol. We don't have to mention 1, 7 because one is the chain initiating group and another is acting as a chain terminating group. So we can simply write heptanediol. Now, how to name this branch? Let's see over here. I'll just write it in a little more expanded manner. So I have CH2, CHO. And now there are 2 ways. What we can do is we can take this as one whole thing, basically count both the carbons while naming the branch, and then take this oxygen separately. In that case, what will be the case? This 2 carbons means ethyl. Okay. And when we leave oxygen out and we do not include, anyways, this will be acting as your branch. So either we'll be using formyl or we'll be using oxo to represent aldehyde. We will not be using ul. Okay. Because this CHO is acting as a branch. Now, whether we have to use formyl or oxo, that completely depends upon how you are assuming your main chain of your branch. So if I take both the carbons into the consideration, or both the carbons I make them as my main chain of my branch, and oxygen is something to which I'm treating it as another branch to my branch, in that case the name will be ethyl for the chain, and this oxygen will be represented as oxo. Okay, and this is the carbon which is the point of attachment. So this will be carbon 1 and this will be carbon 2. Correct. So the position will be 2-oxoethyl. That's how the name would be. But just in case if I do not include my CHO in the main chain, I just say that I have only one single carbon and then CHO as a whole group is attached to my CH2. In that case, this chain name will be methyl. And what will be the name of CHO? It will be formyl. Present on which position? First position, because there is only one carbon which we are treating it as a main chain of my branch. So it can be 2 names. I have by mistake written 2 formyl. I think I need to correct it. Just remove it. Okay. So I have 2 ways of writing the name. Either I can write 4. 4 is the position of this whole group itself. Okay. So this is the 4th position. So 4-2 oxoethyl. 2-oxoethyl means this oxo group is present on the 2nd carbon, and heptanediol is the name of the main chain. This whole branch name can be written as 4-formyl methyl also. That means on one single carbon there is a CHO attached. So here is the difference of the application, and here comes the difference in the name also when you use oxo or formyl, but both the names are correct. Now, if this question you gets in the exam, you have to see what is the name mentioned, and accordingly you have to mark. If both the names are mentioned and the question is multiple answer correct, you have to mark both the answers right. Now look at the next question. Next question, what we have again CHO, CHO, CHO in the 3 places. Again, we will try to find out the longest possible chain. So this is my longest possible chain, again giving me heptanediol. Now what will the name? I prefer using oxo and You will find in the questions also it is preferred to use oxo rather than using formyl. Formyl is little old way of naming. So here that's the reason I have used oxo. You can use whatever you want to, but it's better to use oxo as it because it is a new representation. So we are including all the three carbons of the branch in the naming. So it will be propyl, and oxygen separately, which is present on the third carbon. So it's 3-oxo-propyl, and this whole branch is present on the fourth position, hence 4,3-oxo-propyl heptane di. Okay, so that's how we name aldehydes, and that's how the branch name, or you can say your aldehydes can be used as branches or as the lower priority groups, how we can use oxo and formyl. Everything we have discussed now. Solve more and more questions and you will get better clarity. Now we will talk about some special cases of aldehydes. So now let's talk about the special name of aldehyde, that is alkane carbaldehyde. Alkane carbaldehyde term can be used in special cases. You cannot use it wherever you like. So there are two cases. One is when the chain is cyclic, and the another when CHO is repeated multiple times. So we have seen similar cases in case of carboxylic acid also, where we were using the term carboxylic acid instead of using oic acid. So similar will be the cases in case of aldehyde also. Let's have a quick look on the examples where we are going to use the special names. Let's look at the first question. First question is cyclic hexane and then CHO. So we will write it as cyclohexane carbaldehyde. Instead of writing ul, we are just using the term carbaldehyde. It is exactly the same way how we were using carboxylic acid. Similar way, two CHOs over here on the cyclic chain. So we will write it as cyclohexane 1,2 dicarbaldehyde. This is position 1 and this is position 2. Now we have this molecule where I have a CHO. Sorry, where I have a carboxylic acid and CHO in a cyclopentane ring. Carboxylic acid will get priority because it's high priority group. So I'll start numbering from COOH, and this will be acting as a suffix and this will be acting as a prefix. So the name is going to be cyclopentane 1 carboxylic acid. Again, carboxylic acid is the special name of oic acid, and this CHO, because it is out of the chain and by any way I cannot include it in the main chain for counting its carbon, I will be using the term formyl. So it will be 3-formyl cyclopentane 1 carboxylic acid. Come to the next part. In next question, again I have a cyclopentane with COOH and CH2CHO written over here. So again this is my higher priority group, this is my lower priority group, so numbering will be 1 here, 2 here. The chain will be cyclopentane 1 carboxylic acid. There is no big deal about it. We have to name the branch here, and there can be several ways of naming this branch. One way is I include both the carbons in my main chain of my branch and write it as ethyl oxo, 2-oxo-ethyl, and this whole branch is present on the second position, hence it is 2. Why 2-oxo is written? Because this is carbon 1 of my branch and this is carbon 2 of my branch. Or the other way is I can write it as 2-formyl methyl, sorry, and then rest of the name. But as I mentioned, most preferred way of naming is using oxo. So avoid writing formyl unless it is mandatory and you cannot use oxo there. Wherever the oxo application is possible, preferably use oxo. Okay, so let's see a few more questions. Okay, so next question I have is this, where I have a cyclohexane ring, I have COOH, I have a chain with CHO, and I have a chain with ketone. Okay, again, no matter it is ketone or aldehyde or carboxylic acid, my carboxylic acid is going to get position 1 because it is the highest priority group. So I'll be numbering it as 1, 2, 3 and 4. That's how I'll be naming it, numbering it, sorry. And the name of the cyclic chain will be cyclohexane 1 carboxylic acid. To represent carboxylic acid, we have written separately the carboxylic acid. You could have skipped writing this one, it's completely up to you, or you can mention 1. Now on this third position we have a branch present. Now see, first of all we will write the name of this branch. So the name of this branch, if I include all the 3 carbons, which I said is the best way of naming any aldehyde, that you should count the number of carbons unless it is unavoidable, unless CHO is going out of the chain. If it is possible to count CHO's carbon, then count the CHO's carbon in the prefix. So here I have 3 carbons, 1, 2 and 3. So the name of this chain is going to be propyl, and oxygen is present on the third position, so it is oxo, and I will write it as 3-oxopropyl. This is one branch name. Let's talk about the another branch. Another branch is ketone, and surprisingly, ketone also uses the same prefix, oxo. Okay, so here I have 3 carbons again. So the name will be propyl, and C double bond O is present on the second position. So I'll be writing 2-oxo. And this whole branch is present on which position? Fourth position. Now, if you get such question, let's say the name is given and you have to convert it to a compound, let's say, writing name from compound is easy, but when a compound is given and then you have to convert it to name, how will you figure out where is the ketone present and where is the aldehyde present when the prefix is same? Let me explain you. So here, look at this. So propyl is there, and on the third position is oxo. That means on the last carbon there is an oxygen present. So if it is a 3-membered carbon chain, on last carbon there is oxygen. So this has to be nothing else but aldehyde only. Whereas in this case, again we have 3 carbons, but oxygen is present in the center or in the middle, and aldehyde groups can never be in the middle of the chain. They have to be at the end of the chain or in the beginning of the chain. So this is going to be ketone. So you can understand just by looking at the position of the oxo. If oxo's position is somewhere in the middle of the chain, then it is ketone. If it is at the end, then it is aldehyde. So name is 4-2-oxopropyl and 3-3-oxopropyl. That's the name of the compound. So here I have written 2-oxopropyl first and 3-oxopropyl later, even though the names were same, so alphabetical order was same. So we have just looked at the positions over here and accordingly we have written. So there is no such fixed rule over here. Next compound is CHO, single bond CHO. So 2 carbons. Okay, so ethane, and both are aldehydes, so it has become ethane diol. This is old way of naming. The new way of naming is, as I mentioned, multiple CHOs are there, then you preferably use carbaldehyde, so you can simply write dicarbaldehyde. Whenever you get a question where both the options are there, then you will mark both the options if the question is multiple answer correct. If the question is single answer correct and both the options are there, then you will prefer choosing new way of naming rather than old way of naming. Okay, now look at this compound. Again, we have 3 CHOs here on the carbon chain. One way is I take this as a carbon chain, as a principal carbon chain, and 3 CHOs have been excluded from the principal carbon chain and counting as well. So if that is the case, then I'll be calling it as propane 1,2,3 tricarbaldehyde. So carbaldehyde, when has been treated separately, we are not including its carbon in the principal carbon chain, then we prefer writing it as carbaldehyde. But if I'm choosing this as my main chain, then I have how many carbons? 1, 2, 3, 4, and 5 carbon, and I'm including my CHO's carbon in the main chain. Then we write pentane diol. Okay, and on the third position CHO is present, and that carbon cannot be counted in the principal carbon chain by any way, and that's the reason why we have written 3-formyl. This is the old way of naming, and this is the new way. So using carbaldehyde is a new way of naming. So you will preferably use this way of naming when it is being asked, or when you have choice to choose only one option, right? You will be using the new way of naming rather than old way of naming. In the books it is mentioned this is wrong and this is right, so there is nothing wrong and right in this case. It is just one is old representation, one is new. When multiple answer correct questions will come, then you will have to mark both as the right answers. So here we are done with all the cases of aldehydes. Next we will be talking about the cases, or you can say the Iupac naming of ketones, which is very similar to aldehydes. Only thing is your aldehydes are chain initiating and terminating groups, whereas your ketone is the one which is non-terminating group. That means it is in the middle of the chain and it can be positioned anywhere. So let's quickly have a look on the ketones names. Okay, so next is naming of ketones. What is ketone group? C double bond O is my ketones group. We can also write it as CO simply over here. Here it will be connected to one R group over here and another R group over here. This can be same, can be different. So I can mention it as R and R dash. So carbon chain can be symmetric or can be a non-symmetric carbon chain over here. The suffix what we use for ketone is on, and the prefixes are oxo and keto. So here there is no difference whether you use oxo or keto, both represents the same thing. There are no special cases for oxo and keto, unlike your aldehydes where your formyl was for a specific case and your oxo was for a specific case. So you can use oxo also, you can use keto also. Keto is old representation, whereas oxo is a new representation. Okay, so generic formula for your ketones is RCOR, where again two carbon chains are there side by side and CO is in the middle. So we will be counting total number of carbons total carbons including both the R's, R plus carbon of C double bond O. Everything will be counted to name an alkane, and then it will be ending with one. So it is actually alkane plus one, but because two vowels are together, we are removing E out of it. Okay. For example, the first and the smallest compound what we have is CH3COCH3 in ketones, and this has total 3 carbons in it. So propane, known, and the common name is acetone. I hope you would have heard acetone at many places. Generally for surgical items we use, in surgical spirits and all we use acetone. Next, look at this. So we have CH3CH2COCH3, 4-membered chain where your ketone is on the second position, so we will name it as butane 2-one. Similarly, look at this. We have 5 carbons, CO is on the second position, so name is pentanone, pentane 2-one. The position here can be different. Here you could have simply written it as butane-one also, because no matter CO is here or CO is here, the position is still going to be 2. But in this case, this is position 2. If this CO would have been here, and I think I have written CH2. If it would have been here, then the position would be 3. That's why it is mandatory here to show 2 or 3. In the previous case, you could have simply written butanone. It would have still meant the same thing. Look at the fifth question. Again, it is just a variation what I was explaining. So I've just shifted CH2 here and CO here. CO is on the third position now. So the name of the compound is pentane 3-one. Let's see a few more examples. So I have now a compound where I have 2 COs present, basically di-one. So 4 carbons and 2 ketones. So butane dione, I think I have written butane. Butane 2,3 dione is the right answer. So you have, even if you wouldn't have written 2,3, still it would have meant the same thing. You could have written butane dione, because there is no other possible position where C double bond O can go. It can be second and third position only. Because this is not a terminating group, this is a non-terminating group. It needs to be in the middle of the chain. It cannot be at the end of the chain. If it will go to the end of the chain, it will become an aldehyde rather than being a ketone. Next compound, again we have 1, 2, 3, 4, 5 and 6 carbons. So hexane 2,3 dione. Next compound, I have 1, 2, 3, 4 and 5 carbons. So pentane 2,4 dione. I don't think you should have any doubt over here. Look at this now. I have a C double bond O, I have a COOH, so carboxylic acid, which is a higher priority group. So my numbering of the chain will start from here. I have 2 ketonic groups, 1, 2, 3, 4, 5 and no, not exactly 2 ketonic groups. I have 1 ketone, 1 aldehyde and 1 COH. That's good. So that means COH will be getting the first position, and then automatically other things will get their own respective position. So my ketone is getting third position and my aldehyde is getting sixth position. I told you oxo is the best way to represent aldehyde because that is the new way of naming. So what we'll be doing is we'll be including the carbon of ketone as well as aldehyde in the main chain. Including carboxylic acid. So it will become hexane dioic acid. Now, there is oxygen which is present on the third position, or you can say ketonic group which is present on the third position is also oxo. And this oxygen which is left out is also oxo. So name is 3,6 dioxohexane dioic, out of which one oxo is meant for aldehyde and one oxo is meant for ketone. How will you distinguish between these two oxos? The chain is made up of 6 carbons and on the 6th position there is one oxo. That means the terminal oxo is nothing else but aldehyde and non-terminal oxo is ketone. This is something which you have to understand and keep it in your mind with a bit of common sense. So there is nothing special about it, nothing to mug it up. Your aldehydes are terminating groups, hence they will always be the last in the first position, whereas ketones are non-terminating group and hence will be in the middle of the chain somewhere. Okay, that's how you will figure out the difference between two different oxos, one for aldehyde and one for ketone. Next compound, I have cyclic chain. In the cyclic chain also, we don't have a different way of naming for ketones. We can simply write it as cyclohexanone. If I have 3 ketones over here, the name will be cyclohexane 1,3,5 tricone. So there are no complicated cases in ketones. So it is very simple to understand, very simple to learn. I have not shown you the usage of keto because it is obsolete. We don't use keto as much. In some books it is mentioned that keto can be used, but because oxo is the new way of representing the ketone, we prefer using oxo only. Now I'll give you some questions, try out on your own And in the next class, or you can say in the doubt class, we can discuss the answers for these. And in the next session, we'll be talking about nitriles and isocyanides, amides. These will be the groups for which we'll be doing the naming. So this is your homework. These are the questions. Try out them on your own. Solve these questions. I will share the answers in the group. And if you have any doubts in these questions, then only we'll discuss it in the doubt session. Okay? Till then, bye-bye.